Alright, here's a video going over the rules for negation elimination, negation introduction, and double negation. I'm going to do all three rules because they're usually used in tandem. So if you use the rule of negation elimination, you'll probably go on to use the rule of negation introduction. And then sometimes afterwards, you'll need to use the rule of negation, or double negation, I'm sorry. So first we'll do the sort of schematic definition, as you can see on the back of the cover. It has the list of that. And so the rule for negation elimination basically lets you write the lambda. The lambda is just a symbol that signals that there's a contradiction within the proof. So the contradiction should look something like not Q and Q, or it doesn't really matter the order, just as long as you have the opposite formula in your proof. And so if you have not Q on some line, call that line J, and then its opposite Q on line K, you may use the rule of negation elimination, citing or referencing J and K, which are the formulas that produce the contradiction, and then writing the lambda to signal that there's a contradiction within the proof. The dependency numbers will be on the left-hand side, and they'll consist of the dependency numbers that make up J and K. So you'll write both J and K's dependency numbers on the left of your lambda. So after you have the lambda, you can see that the rule of negation introduction has a lambda in it, right? And so here, once you've derived the lambda from negation elimination, you can use negation introduction. So negation introduction is the second discharging rule that we learn, and in each of the discharging rules, you'll see that there's an assumption within the rules. This means that this line, right, this formula, must be from an assumption. So since we can always assume at any line, it's pretty safe to say that we can always use this rule once you derive a contradiction. Okay, so the use of negation introduction is very important because it lets you negate whatever formula that you assume. Here, if your assumption is J, of course the dependency number will be J, and is an assumption, you can use that along with a contradiction to create a negation, saying that it's not P. So all you have to do is reference the assumption, J, on line J, the contradiction on line K, and cite the rule of negation introduction. Here, likewise, for all discharging rules, what happens is that J, the line of the assumption, the formula with which you're negating, is left out of the dependency number. It's discharged once you use negation introduction. So sometimes you'll assume not a straightforward atomic formula or a complex formula that is in the positive, but sometimes you'll assume a negative formula or a negated formula. Once you assume a negated formula, if you add a negation onto that, it's going to create a double negation. And so the rule of double negation lets you take away two negations at a time to create a sort of positive formula. So the formula not P on line J can be sort of turned into P with the rule of double negation on whatever line that the double negated formula comes from. So those are the three rules. Let's see them in action. I'm going to prove a simple sequence to show the rules in action. Okay, so let's prove this. Not A and not B entails A arrow B. Okay, so we have one premise to work with. It's negation of A and not B. On the second line, here's a negation. It's really hard to work with negations because the negation rules don't actually let you derive anything from negations, although it lets you make a contradiction. So what we have to look to see where we have to go is the conclusion. Here it's A arrow B. To make an arrow, we need to use arrow introduction. And so to use arrow introduction, or conditional introduction, I'm sorry, here it is, you need an assumption, right? And so here we'll assume A because that's the antecedent, which matches the sort of structure to the rule. So we have to assume A, and here I'll write my note that I'm going to discharge it when I use arrow introduction. Okay, and now once we assume A, we have to try to derive B. As you can see that B can't be sort of derived from the premises. There's no B around to work with. And so what we're going to have to try to do is, of course, assume its opposite. And so this method is called method of reductio ad absurdum, where you assume the opposite of what you want, try to derive a contradiction, and then use the contradiction to negate what you assumed and create what you originally wanted. So we originally want B, so the opposite of that is not B, so that's what we'll assume. Right? You can write RAA for reductio ad absurdum, or you can write negation introduction. I tend to just write negation introduction. So there's our third line. As you can see here, once you assume the opposite of what you want, we said that we needed to derive a contradiction. And so we have to look for a contradiction. If you can see, here the opposite of the negation of A and not B is A and not B. And so we have A and we have not B. They're on two separate lines, but of course we can put those together by conjunction introduction. Right, and so the lines being used were 2 and 3, and so the dependency numbers would be 2 and 3. So here we've just put the atomic sentences together to make this more complex formula, and this formula is the opposite of that formula. So 1 and 4 create a contradiction, right? So lambda 1 and 4 creates the contradiction, and the rule that sort of allows us to write the lambda, or allows us to signal the contradiction, is negation elimination. And so the contradiction is from 1 and 4, and so it's true if 1 and whatever 4 depends on is true. So it's 1, 2, and 3. So after our contradiction, right, we said that from the contradiction we can use the lambda to produce a negated formula, right? And so here our note is going to tell us which assumption to negate. And so we're going to negate what's already negated, right? And so we always have to add a negation. We never remove negations, except for we remove 2 negations, as you'll see right now. So here from 3 and 5, we're going to use negation introduction, right? 3 and 5, negation introduction, and then produce not B, right? And so because this is a discharging rule, right, we use an assumption with a discharging rule, and so we must discharge 3. And so 3 remains outside of the premise, I'm sorry, not premises, dependency numbers. And so it should be 1, 2, and 3, but we exclude 3, just like what the rule says. right? J is excluded. The assumption is excluded. Okay, so lastly, not lastly, but almost there. Here is the double negated B. And so the rule of double negation allows us to derive B from not B. And so that's from line 6, and the rule is DN. Right? And so here the dependency numbers will follow straight through. Then on line 8, right, we can put it all together because we said that once we've derived our consequent, we can combine it with our antecedent and produce A arrow B. Right? Antecedent is from 2, the consequent is from 7, and the rule that allows us to produce a conditional is conditional introduction. Right? And so the dependency numbers should come from 2 and 7, but remember that this is a discharging rule that says that if you're going to use the assumption with this rule, you must discharge this line. So the dependency number should be only from 1. Okay, so that covers the basics to negation, elimination, negation, introduction, and double negation.